Okay. Hi, I'm Sophie. I'm one of the TFs for CS76 building mobile applications. And today we're just going to be going over a primer of Java. So we're just going to be going over installing Java on your computer, coding in Java, some basic operators and control flow statements, and some other features that are unique to Java. Okay. So I guess the first step to running Java programs and ultimately be writing Java applications is installing Java on your computer. So to install Java on a Mac, it's pretty simple. It's already installed on there. So you just go to the software update tool. So you can actually go through your JDK and see if you have the correct Java versions installed. For PC, you go to that link right here, and you choose JDK 7, and you can download that one with documentation so you can actually develop on your local computer without internet access. So I guess when we code in Java, you can actually use any text editor you'd like, whether that be Nano on your terminal or PuTTY, or like a more advanced IDE such as Eclipse. So I actually recommend using Eclipse since we're going to be developing in Android later in this course. And the best thing to download, or the best version to download, there's quite a few versions, would be Eclipse Classic. So let's go and see right here. You see that there are many different versions of Eclipse right here. So the best one to download would probably be Eclipse Classic, since it's not just for Java. You can use it for other programming languages as well. Okay, so I guess we'll start with the fundamentals of Java. So every single Java file has a .java extension, similar to if you're coding in C, you'd have a .c extension. You'd have a .java extension for Java, and all of your Android files, all your source files would have this .java extension as well. The next thing would be having a class definition right here. So every single source file needs a class. So each of these class definitions are compiled into separate class files, and when you actually go through your file manager and look at the files in your directory, you'll see, let's just say we have hello world.java. When you compile that, you'll also have hello world.class. And the class file and source file need to match. Otherwise, you're going to get some errors. So let's just say you have public class hello world in lowercase, and then your file name was called hello world with mixed cases. Then you'll receive some kind of error. And you also, in each program, you should include at least one. You should include one main method, so the program knows how to execute your program and in what order. Okay, so next step after you write something, we'll go over how to write a hello world program later on, but you want to compile and run your Java program. So you save your program with the .java extension, and then you also compile your file. So you go to your terminal by typing javac file name. So in the case of hello world, you'd have javac hello world.java. And after that, if your compilation is successful, so you would not see any errors. You would have just javac hello world.java, and then in the next line it would automatically return. And then you know that you have created a successful class file, and then you can run Java hello world, just like that. Okay, so we're going to just go through and just try to run the hello world.java program. Okay, so let's look at the hello world.java file. So in this case, I am running it from a text editor within the terminal called Emacs, but you can also use Nano or Vim or whatever is suitable for you. Okay, so this is our basic hello world file, hello world.java program. And as you can see, we have a class file named here, and that hello world matches the hello world.java file we just named. And we also have a main method, which tells our compiler and our program like in what order we want to execute some lines. So in this one, we're going to just print out hello, comma, world. So this program will print out hello world. Okay. So we can compile this program by typing javac hello world.java. As you can see, we don't have any errors here. So we know that we completed and successfully compiled a program. So the next step we can do would just be to run our new file, our new class file. So what we would do would be java space hello world. Just get rid of the .java extension when you're actually running the program. So as you can see, it did exactly what we wanted to do, and it printed out hello world right here. Does anyone have any questions so far? Okay, so I guess we can go to the next. Okay, I'll also show you how to run this hello world in Eclipse as well. So we'll go to source, hello world.java. As you can see here, there is a, you can either press F5 on a PC laptop, or there's a run command here, this green arrow right here where the laser pointer is pointing at. If you click that, then it will also run your file, and it will actually compile and run your file at the same time. Okay. We're going to actually run this as a Java application. Editor does not contain a main type. Okay. Actually, I'll show you how to do that in later examples, but you can also code up your Java files right in here. Okay, so some standard naming conventions in Java. So for our class names and interface names, so class names being like public class hello world, like in that last example we had, each internal word is, the first letter of each internal word is capitalized. And so that's why we had the capital H, hello, and then W, O-R-L-D. And all lowercase method names, variables, so that includes things like the main method, or I guess if we have another variable like int x, it won't be like capitalized X. And constants, which are like the max value of an integer, would be in all uppercase. Okay, and here are some fun terms that we use in Java. So we use the words like class, methods, and object. Those are probably the biggest or the most common used terms in Java. So a class is just a template that we use to create different objects, which define the objects like properties and behaviors. And methods are similar to what you would see in any other programming language. So main is a method, and you have that C equivalent as well. An object, instance of a class creating using the new operator. So a string, for example, is an object. And as you saw from the hello world example, when we had the main method, we had string bracket bracket args. So in that case, string was our data type, but its first letter was capitalized because it's an object, and an object is kind of like a class in that sense. Okay. And the last thing we'll be going over, just Java fundamentals before we actually start looking at source code, is method overloading. So this is two or more methods in the same class that have the same name but different parameters. So let's just say we have a shape class, and We have triangles and squares. So in that case, we can, I guess we can define the lengths of the sides using methods in the shape class. So we can have like define or set side lengths in side 1, side 2, side 3 for a triangle. But for a square, we can have set side lengths in side 1, side 2, side 3, and side 4. And the compiler will, based on the actual like instance that you're programming in, it will decide which of those two methods or two or more methods that you've overloaded is suitable for that specific task. All right, anyone have questions? Okay, so I guess now we're going to go into some source code. So I guess the first example we're going to go through is going to be sample1.java. Okay, so in this case, as you can see here, we have our class name and also our main method name. So that's what every Java program needs. And in this case, we are just defining some data types. So we'd have double, truncated double, we have ints, and we also have strings. So for this, when you're dividing ints by other ints and you want your result to be a double, the result is going to be truncated. So in this case, 8 divided by 3 without any decimals behind it will return 2. So when we actually run this program, the first line will be truncated double colon space 2.0. For a non-truncated double, it will give you the actual full result when you actually specify the actual, I guess, some actual significant digits after the decimal point. And an int and a string work in the same way as they do in other languages. All right, so let's compile this program then. So we're going to use Java C sample1.java. Okay, and you see we don't have any errors there. So we're just going to do Java sample1. And from there, as I said before, you'll see that you have the truncated double. Remember from the source code that it was 8 divided by 3, just 2 ints divided by each other, but we wanted a double result. So we got 2.0. And for a non-truncated double, we got the full result. It's kind of rounded strangely, but we do have the number 2.666, so I guess similar to the answer you'd get from a calculator. And the other int 7 and the string also print out the same way as you'd normally see in another programming language. Let's just go back to that example again, and we can see that Java is different than a language like C in some other cases. So in C, when we want to print things out, we would see that you'd have like a %d or a %f when you wanted to print something out. But in Java, we can just, I guess, concatenate the variable name right after. So we don't need that %d, comma, and then the variable name that corresponds to the different special symbols. But instead, we can just concatenate it right here. All right, let's go to our next example then. Okay, sample2.java. All right, so in this case, we're going to look at formatting for Java. And with formatting, we have special characters such as \n. So can anyone tell me what \n does in this case? Yeah, so it goes to the new line. So having this \n, it will let the computer know that you wanted to print that what's following it. So I guess in this case, int colon space 7. With this new line character, it will print the TF name and this part right below it to a new line. And other special characters include like \t, which means that you're creating like a tabbed space in between the two areas that you want to include. All right, so let's run this program, Java C sample2.java. And then we have no errors, so we're going to run Java sample2. So here, even though the formatting for the print lines look different, we can see from here, this is the output for sample1. It's the same as the output for sample2. So \n does the new characters, and you can also use other special characters to do other print formatting. Okay, so I guess we'll go on to the next example, which is going to be Emacs sample3.java. All right, so I'll actually put this on to show the whole thing. Or actually, we can go line by line first. All right, so in this case, we're actually going to be looking at control statements and arrays. So control statements include for loops and if statements, while loops, etc., similar to any other language. So here we are, I guess for this example, trying to show different ways you can initialize arrays in Java. So the first one, we're just declaring the array teams. And for the second one, we are initializing it to be an array of strings that only have 2 spots. And in the last one, we are actually initializing these spots to different values. So in this case, this is one way to initialize and declare the contents in an array. All right. So the second way to do this would be to do it like this. So we are declaring, initializing, and putting everything into the array all at once. So points by team, I actually did this before halftime, so it's kind of off. But we'll say that we had created an integer array with 2 spots, and these spots are initialized to 9 and 10, respectively. Okay. And the third one is actually exactly the same as what we did with the points by team array. Great. Any questions on how to do arrays so far? Okay. So I guess I'll go down to the next lines. Okay. So we're at this print line. So the print line works in the same way as it did in the hello world example. And the for loop, the syntax is similar to other languages. So we initialize some kind of variable, counter variable here. And then we have the amount of times or when we want the loop to stop. And here is the iterator variable that we want to do after every single loop iteration. So here, I'm looping through this loop twice, and I'm just going to print out the team name because of what we have here, and also the points by team here, followed by a tab. So we would print out, in this case, with what's initialized here, we would print out New England Patriots : space 9, and then with a tabbed character, and then New York Giants : space 10, even though that was wrong at the time, never mind. And then followed by a new line character here. And we'll see the output later when we actually run this program. But another way, if you just want to iterate through the array, we can use this other syntax, so total points per quarter dot length. So this is a method in the arrays class, and this length method will return an integer amount of how big the array is, or how many elements there are. So in this case, it will iterate based on here 4 times, because this is the length of this total points per quarter array, and it will print out quarter I colon this, each quarter on a different line. All right, so let's compile and run this program now. Okay, so we have Java C sample3.java. Okay, and we have no errors there. So the next step we do would be to run the program. So Java space sample3. As you can see, we have the print line that we put there, and then New England Patriots 9 and New York Giants 10. So what this does, \t, this must be the place where the next tab is, so that's why it's there. And we're printing through that total points per quarter array, each on a new line. So it iterated successfully over the array with the 4 spots. So let's look at the next example then. Feel free to interrupt me if you guys have any questions. Okay, so we'll look at sample4.java now. All right. Okay, so in here, we're actually introducing the objects thing right now. So we're creating a team object. So each object is we're going to put it into a class. You can't just say object team. So to initialize and set the properties of an object, you put it into a new class. And here we have each team has its name and score corresponding to it. And you can when I said we can initialize objects using the new operator, you can do something like team New England Patriots equals new team, the Patriots in string form, and also the score that they got in the game. And when you do this, this means like the context of the method, the object. These variables up here rather than the ones down here. So the ones down here are name and score just normally, and then this refers to the variables that you've declared up here. Okay. All right, so we'll keep going down. So in here, we're just setting and getting the fields that are in each team object. We normally use these getters and setters when you have when you're doing Android programming and you have RSS feeds, for example, and you are creating a huge RSS item object, and in there you're doing dates, description, links. So we use getters and setters for that. And because those keep changing within a link if you're caching the items, for example. And then this toString method, it's kind of like a Java standard to include a toString method in an object. So that's why this is here. Okay, so let's go down to the actual the stuff that we actually care about, which is running this program. Okay, so so this sample4.java is the name of our program file, and up here, sample4, it matches the class that we have it in. And this class has a main method, and then in here is our actual program. So let's just start looking line by line within this main method then. Okay, so we're creating an array of teams, and we're creating a new team object. So arrays are also objects, and we're using this new operator to initialize this object. And we're creating an array of teams that is of size 2. And then the next thing is that we are initializing each of these spots to actually hold teams. So we have teams in Zurul array bracket 0. So that's the first element in the array. And we put something in there because we haven't created any teams yet in the code. So we're creating a new team object with its name being New England Patriots and its score being 10. So if you don't put any of the fields, it will automatically set it to, I guess, the null value if you have a string, or the 0 value if you have like an integer or a float. And we're doing the same thing for the New York Giants right here. And this is some pretty printing thing that I felt like doing. And then right here, so we're setting 2 iterator values, or just 2 integers, in I actually being the iterator value. So we are iterating through the number of teams, and going to iterate through this loop twice because teams in Super Bowl is of size 2. And then here, we're printing out the name and then the score that it got. So as you can see here, we're using 2 different syntaxes for getting object fields. So you can do it either this way, teams in Super Bowl I.name. But when you do that, you need to make sure that your file or your field names that you initialize up here are public. Otherwise, you won't be able to do the .name because that's that would be like a private or a protected field. So to make sure to only use the .name syntax, you need to make sure that the field in the other class is public. So all the classes that are referring to it can see it. Okay. Same thing, we are using the getScore method right here to get the score of the team down in the print line right here. Same thing with that. So if your field up above is not public, then you can use this getScore or getName function that you created, granted that it's also a public method. Okay. Anyone have questions on using objects in Java so far? Okay. Let's go and compile and run this program then. Okay. So Java C sample4.java. And then we run it by saying Java sample4. So as you can see, it just printed out the Super Bowl score. I guess this is as of halftime when I was making these slides. So New England Patriots 10 and New York Giants 9. So as you can see, the 2 ways of getting the different fields in there worked in the same manner as each other. All right, so let's go to our method overloading example then. Emacs sample5.java. All right, so for here, we're creating a shape object. And notice that we didn't make these fields public since we're actually going to be using our getters and setters later in the actual program. So here, we're just creating a constructor, which is letting the compiler know how to initialize this object. And right here, we are setting the side. Here we're getting the side. And here, this is actually where things get a little bit interesting since we're doing some method overloading. Okay. So notice that these two methods have the same name, but different parameters. So we're just going to say that this is setting the side lengths for a triangle with 3 parameters, side 1, side 2, and side 3. And here, this second method, the second set side lengths method, has the parameters of side 1, side 2, side 3, and side 4. So we'll go down to the actual program now and see how these are used. Okay. So see that we're calling this set side lengths method for each of these different shapes that we have. So the set side lengths method, for this one, it will refer to the first set side lengths method that we included in our shapes class. And the second one, when it compiles, it will refer to the second set side lengths method that we declared in our object. Okay. So any questions on this part? Okay, so let's run this program just to make sure everything is in working condition. Java sample 5. Okay, as you can see, in my toString method, I included how to print out each shape. So that was the number of sides and the side lengths, and it printed each side length separately here. Okay, so I guess for the last part of this section, that's all the code examples I have, but I'll show you how to actually compile this in Eclipse, since that's what you're going to be using for, I guess, the first half of this course. Pointer is over here. Okay, so we'll go to use Eclipse. So notice that these files are all the same. Okay, actually expand this out and get rid of this. All right, so here we're going to see how we run files. Actually, not that part. Okay. Okay, so here we're going to find the run button. Or actually, we are going to use the run button. So when you have it on an apple, you can't really see it here, but I guess I'll kind of draw it out over here. So in your window, you have, for a Mac at least, you have this toolbar here. This has your Apple and your program name, which will be Eclipse in this case, since we're using Eclipse. And one of these functions is the run dialog. With this run dialog, when you press it, you'll have this menu come out, and run is the first, should be the first item that you have in this menu. So let's go back here and run that program. The other, I guess, shortcut if you're on a Mac to use the run command would be to use Shift Command plus F11. Editor does not contain a main type. Okay. Okay. So actually, let's just write a new program, a new class then. Let's just call it hello section. So in here, we're naming the class file, and in here, this is the folder that it's going to be in our Eclipse Package Explorer. We can put it into a package. So for Android, this is really important to be able to put your source code in packages. So I guess I'll start using that thing right now. So I'll just put it com.harvard e76.java primer. So like you usually put Java code or Java files into into packages based on, I guess, the utilities that your files are in. So like let's just say you had Android activities. You'll be learning more about this next week, but you'll be putting it into like com dot, let's just say my own folder, so com.sophiechiang.activities. That will be where the source files for all my activities will be, and if I have some kind of like network utilities, I'd also put them in a different package called like com.sophiechiang.network. So let's just start this right now, com.harvard.e76, or put CS76 .java primer, with the section being hello section, or name being hello section. Its superclass being objects, so this means that it doesn't really inherit from anything that's, it doesn't really inherit specifically. And we can create a method stub, public static void main, since we're going to be using this in our Java class that we're going to make. And we'll just finish here. Okay, so you can see here, it tells us that we need to write something here into our main method. And it already creates these Java docs for us, so you can write some comments on your code as you're going. But right now I'm not going to really focus on that, and I'll probably focus that on next week's Android section. Okay, so let's just write something simple, system.out.println. So what's good about Eclipse is that it comes out with the methods that we have right here. And it makes for really easy programming, since you don't really need to know the exact methods. You can just type out some simple, type out the beginnings of the words, and this menu will pop up and let you know what methods exist, and also, I guess, what parameters you can have inside. All right, so we're actually going to continue printing in here, and we're going to just write hello section. All right, so hopefully this will run correctly. Editor does not. Okay, this worked yesterday. Okay, so let's just consider that it worked correctly. Down here, there's a console. So in the console, we'll actually have, it will print out like the exact output that this program would print out otherwise. All right. Any questions on using Eclipse for Java? Sorry?
Why is that not working?
I'm actually not sure. I'd actually probably figure it out if you want to stay a little bit afterwards. Yeah, maybe. Yeah, it was actually working yesterday. So let's see. Run as Java application. Okay, well, actually, if you want to stay after section, I'll actually get this fixed up and show you how it works. You'll be using this a lot, not necessarily for Java specifically, but for Android as well. This is going to be your main go-to editor for Android, and I guess next week we'll go into more detail on how to use Eclipse. But that's the section for today. Thanks for coming, everyone, and have a good week.